We're in Algebra 2 at 10.2a, and Chapter 10, we're going to introduce conic sections. I have two previous videos, one where we talked about the distance formula and the other one where we talked about the midpoint of a line segment. If you haven't seen those or you become lost or confused, just click on this description and you can watch them. A cone is formed by rotating one of two distinct non-perpendicular intersecting lines about the other. So we have this blue line coming down the center, don't we? And actually, we can go like this, can't we? So it's in the very center. And if we rotate around that line, we make a cone, see? And any position of the rotating line is an element of the cone. So these spots right here, these are elements of the cone, right? The intersection of any plane with a cone is called a conic section. So here we've got some conic sections here in our picture. We've got a circle. It's coming straight across. An ellipse is on an angle. The parabola is on an angle. And it's not a full circle or oval, is it? And then we have a hyperbola. And it doesn't look like it, but it's supposed to be cutting straight up and down for the hyperbola, okay? So those are some conic sections, all right? So let's break down each one a little bit. In this chapter, we're going to go over each of these more thorough, but this is just an introduction. So a circle, we know what a circle is, right? It's the set of all points in a plane that are at a constant distance, the radius, from a fixed point in that plane. And the fixed point is the center of that circle. So if we took a plane and sliced it through the cone, we'd have a little circle there. See? An ellipse in a plane, it's the set of all points P such that the sum of the distances from P to two fixed points, f sub 1 and f sub 2, is constant. So this ellipse right here, see that? So if we were to put a sheet of paper or cut it like this, we would make an ellipse, see? Each fixed point is called a focus, and the plural of focus is foci. Now, some people say foci, which is okay, potato, potato, it doesn't matter. A lot of people think it's foci because ci generally says the s sound, like in the word city in English. Now, for focus and foci, what the heck is that, right? It's a point that has the property that the distances from any point on a curve to it and to a fixed line have a constant ratio for all points on the curve. What does that mean? Okay, we'll take a look at this drawing, all right? We've got point A on this oval and point B, all right? Here's a focus and here's a focus. The distance here is 3.2 from A to that focus, f sub 1, and the distance here from A to this focus, that would be f sub 2, is 6.8. When we add them together, we get a 10. Now this point B, the distance from here to f sub 1 is 5, and to f sub 2 is 5, and we add them together, it's a 10. So in total, the distance from A to the foci equals the distance from B to the foci. See that? We're going to get into this deeper, all right? I just wanted to show you that that's a focus and that's a focus, all right? F sub 1, f sub 2, all right? So now we have parabola. And we've done parabolas so far, right? In a plane, the set of all points equidistant from a fixed point, the focus, and a fixed line, the directrix, that's a new word. The graph of a quadratic function, y equals ax squared plus bx plus c equals 0, as long as that a is not a 0, is a parabola. And it's the only conic section that fits the definition of a polynomial. So here's our parabola, okay? And a directrix, well, it's a fixed line used in a description of a curve or a surface. So here's our parabola. It's opening upward. Here's our axis of symmetry. The directrix is perpendicular to it. It's a fixed line. See? That's a directrix. Then we have a hyperbola. And a hyperbola is like a plane cutting through the side of the cone. See? Like this. That makes a hyperbola, going straight up and down when we cut. See? Here's another one. It cuts parallel to the cone axis. See that? In a plane, the set of all points P, such that the absolute value of the difference of the distance from P to two fixed points, f sub 1 and f sub 2, is constant. So to the focus, it's constant. And the fixed points are the foci. Now, don't confuse hyperbola for the word hyperbole. Hyperbole has an E at the end. This has an A at the end for geometry. This just means an exaggerated statement that's not meant to be taken literally. Like, I told you 1,000,000 times to put your shoes away. Well, I probably told you 12, but I say 1,000,000, so it's an exaggerated statement. That's hyperbole, okay? It's usually used for jokes and making funny statements, mostly. Our next video, 10.2b, we're going to talk about equations of circles. I'm going to add this to the Algebra II playlist. I'm going to have links to those 2 previous videos for Chapter 10, so you can just click on this description and watch them. And we're going to start getting into all kinds of cones, all right? Okay, hope this was helpful. Hit the like button if it was, and I'll see you next video. Bye.